My name is Miranda Wang, and I'm the co-founder and CEO of BioSelection. I started working on solving the plastic problem since I was a high school student in Vancouver, Canada. My current co-founder and I met each other at a high school recycling club meeting, and we thought that recycling was just a matter of putting things into the right bins. But when we visited a waste transfer station in 10th grade and saw how much plastic was mixed with the organics and all that waste in that waste plant, we realized it wasn't, recycling was something that needed a technological breakthrough, a real industrial system to be able to deal with it. It's not just a change of behavior, consumer behavior. So since then, we've been working on developing new solutions. We pivoted a couple of times. We actually started by looking at bacteria that can eat plastics and presented this at the 2013 TED conferences. When we realized that that method wasn't as scalable, we pivoted to the current chemical technology, which is inspired by research funded by the DOE. We start with dirty plastics. So what you're looking at here is post-consumer plastics. A lot of them are polyethylene bags. We focus on polyethylene. This is sourced from Green Waste Recovery, which does all the curbside collection and processing for over 40 jurisdictions in Northern California, and they're an official pilot partner of ours. So what happens is that this type of plastic gets shredded, and then we load it into a reactor system that we have, and we currently use a glass system. This is a very tiny version of what we have. The current size we actually have in the lab is about the size of me, so we're scaled up much more than that. On a molecular level, these plastics look like this. They're very long carbon chains. And we have a catalyst system that basically breaks apart these carbon chains and make molecules that look like this. So they're shorter biodegradable molecules that can build up to all types of materials. And in real life, these are the chemicals that we have made from the plastics. And this is what the commercial grade looks like. So with the Pritzker Prize, we can get from here to here. And that would make us, this technology, fully commercial. Our business model is sustainable and profitable. So our business actually makes money in two ways. The first way is that we provide a plastic processing service to material recovery facilities. A material recovery facility today sorts out polyethylene plastics mandatorily, because if they don't pull it out, it contaminates the cardboard in the system. So it doesn't cost them anything extra to pull it out of the system. They already do it. But there's nobody who can recycle this plastic today, so they have to landfill this at the tip fee of $50 to $120 per metric ton. So we are inserting ourselves by providing a service to process this material at a price comparable to the landfill. The second part of our business is that we sell the chemicals coming out of the processor. And these chemicals, we plan to actually just sell them exactly at market price, because the total cost of our system is so low. We are actually able to generate total revenue of $2,500 per metric ton of plastic pushed through our process. We don't expect our technology to give consumers a reason to continue relying on single-use plastics, because we actually integrate ourselves directly into the existing recycling industry by filling a gap. Today, consumers are putting these plastic films, polyethylenes, into the blue bins, but this is not actually being recycled because there's no technology to address it. So by working with waste companies, we can ensure that this plastic doesn't go to oceans and landfills. And we also work with companies to take this waste out of their existing supply chain at places where a consumer would have no control over. For example, we're doing pilots with Adidas and Unilever right now on packaging that they use to protect their retail products. So also the chemicals that we make are able to synthesize materials that are essential today, but it can only be made from virgin petroleum. So by providing these chemicals to the market, we're offering the first plastic waste-based renewable option that is better than oil and also at the same price. And also these chemicals can be used to make compostable materials like PBS to replace polyethylene. In the future, we're building a world where this technology will not only directly make an impact by preventing plastics from becoming pollution in oceans and landfills, but it will also be able to reduce carbon emissions, both in landfills as well as in the process of creation of these chemicals, because we're creating these using the carbons that are locked in the plastic waste, and we're displacing the chemicals made from petroleum today. But we have even grander dreams beyond this. And the first is that by expanding our technology so that it can deal with other types of plastics like polystyrenes and multi-layer packaging, this technology can become the pillar of what would enable people around the world to open up landfills and essentially mine plastics as a new carbon source. So plastics would be the new oil. And so that we don't have to drill for oil anymore to make the things around us. And the second thing is our team will be working on pushing the frontiers of innovation for these chemicals that we have, so that we can synthesize more sustainable and biodegradable materials, for example, like PBS, and there are many others, so that we can actually turn the carbons that are used today in plastics and move them into materials that can be used over and over again as renewable and biodegradable contents.